Hi guys, in this video we're going to talk about techniques of integration for algebra. Now, there are 5 techniques of integration for basic algebra. The first one is when you integrate a constant k, you always get kx plus c. Example, if you integrate number 5, we'll get 5x plus c. If you integrate axn, the general term of algebra, we get ax increase the power by 1 n plus 1 divide n plus 1 plus c. Well, classic example, I may give you ax power, say 5x power 3. So when you integrate this, we copy 5, we copy x, increase the power by 1, 4, divide by 4 plus c. The third one is what we call the reciprocal term, where the x has a power n, but it's 1 over, it's below. So we put a negative in front, copy a, copy x. Now instead of increasing the power, we reduce the power by 1 and we divide by the reduced power plus c. Well, for example, I may give you, let's say, 7 over x power 3. When you integrate, put a negative in front, copy 7, copy x, reduce the power by 1, 2, put a reduced power in front plus c. Okay, number 5. When I integrate composite function k ax plus b, power n dx, we can copy k, copy ax plus b, increase the power by 1, divide by the increased power, and we differentiate inside the bracket. And differentiate ax plus b, you get a. Now take note of the similarity between number 4 and number 2. Number 2, you don't have a bracket. Number 4, you have a bracket. And also, take note that whatever inside the bracket must be linear. This technique or this formula is only valid if the expression inside the bracket is in linear form. Example, let's say if I have 3, 2x plus 5 power 4. So when we integrate this, we copy 3, copy the bracket, increase the power by 1 becomes 5, divide by the increased power 5. When you differentiate 2x, you get 2 plus c. And of course, you can simplify this. You can write this as 3 over 10, 2x plus 5 power 5 plus c. Number 5. Now, number 5 is similar to number 3. Number 3, you can see the x is below. But number 5, you have a bracket. And now the bracket is written below. So when you integrate this, you want to put a negative in front, copy k, copy the bracket. Now again, instead of increasing the power, you reduce the power by 1. You put a reduced power in front and you differentiate inside the bracket. And differentiate ax, you get a plus c. Example, you may have, let's say, just use random number 4, 3x minus 2 power 6. Okay, so we put a negative in front, copy 4, copy 3x minus 2, reduce the power by 1, 5, put a 5 in front, differentiate inside plus c. Again, you can simplify this and write this as minus 4 over 15 with a 3x minus 2 power 5 plus c. Okay, there you go. These are the 5 basic techniques of integration for algebra. But of course, the next question is, when do you use what? Now, maybe I go through the next. I'll give you a general case. If you have an expression like this, 3x power 4 minus, let's say 2 plus 5 over x power 2. So this is a case involving the first 2 or 3 of the first 5 formula. So you can see that the first one, you will be using the axn, where the x is above, so increase the power by 1, 5, divide by the increased power. 2 is a constant. When you integrate, you get 2x. Now this is the case where the bracket is below, the x is below. You put a negative in front, copy 5, copy x, reduce the power by 1, 1 plus c. Simple. Now in the event that you have a bracket, let's say I give you a simple example, 2x minus 3 and x plus 4. So we can't integrate this directly. We have to expand the bracket first. 2x squared plus 8x minus 3x is 5x minus 12 dx. Then we integrate 1 by 1. This will be x power 3 divided by 3, 5x squared over 2, and 12x plus c. Alright? Now, what if you have a bracket like this? Let's say x minus 3 over x squared dx. Now take note that we cannot use composite function, the one that I mentioned earlier, because the one inside the bracket here is non-linear. It's actually x power negative 1 here. So you have no choice but to expand this bracket. This will be a squared 2ab, which is 6, right? And then b squared 9 over x squared. So when I integrate one by one, I get x cubed over 3, 6x minus 9 over x plus c. I hope you know this is using the axn. This is involving constant, the first one, and this is the one involving reciprocal, the third formula. And another example is, what if you have, let's say, 6x squared minus 4 over 2x, I'll put a square dx. Okay, so what if you have something like this? Now you cannot integrate directly. Now unlike differentiation where you have product rule and quotient rule, integration don't have that. Yeah, so we have to expand, or should I say separate them into two. This is quite straightforward because we can simplify these two, cancel that with 3. This is 2 over x squared, and then when you integrate 3 you get 3x. Integrate this, you get negative in front, copy 2, copy x, reduce to power 1 plus c. Okay, so these are some example of how to integrate simple algebra. Okay, now let's move on to the next part, integration, using integration to find the equation of the curve. So now let's say you have an equation of the curve y equals to 3x squared minus 4x plus 5. Now let me just recap. But in differentiation we learned that if I go and differentiate this dy dx, I will get 6x minus 4. So what we want to do is we want to work backwards. This is called equation of the curve. Okay, this is called gradient function. Yeah, it's a gradient function because it's a function that represents the gradient of the curve. At different x value, you have different gradient. So now, to integrate this, right, we have to write integration of 6x minus 4 dx. Now take note, when you integrate 6, we copy 6, copy x, increase the power by 1, 2, divide by 2, integrate 4, you get 4x plus c. Now the thing is, we do not know what is the value of c. So most of the time they'll give you a coordinate. Let's say they say, oh, this curve passes through point, let's say 1, 5. So when I sub in the coordinate 1, 5, my y is now 5. So, or should I say 1, 4, just to make sure that this is the same as the question above here. So this is 3 minus 4 plus c. My c is now 5. So the curve will be the same as this curve. But take note, again, it may not be the same all the time because it depends on the point where the curve lies in. I mean, the curve passes through. So the curve may pass through this point, may pass through another point, 1, 4, it may pass through any other point. So that's why your c value may differ. Right? C represent your y-intercept. Okay, so let's say, I'll give you another example. Let's say a given gradient function, and now I give you in the form of a composite function. Let's say you have 3x minus 4 squared. So if I want to find the equation of the curve, given that this is a gradient function and it passes through point, let's say, make it easy, 1, 2. So we can, number 1, integrate this function. You copy the bracket, increase the power by 1, divide by the increased power, and differentiate inside the bracket. But remember to put plus c. And our goal is to find the value of c. We have to sub inside 2. Your y is 2. When x is 1, if I put 1 inside 3 times 1 is still 3, minus 4. Power 3, this will be 9 plus c. So this is negative 1 over 9. When I bring over, my c is 2, 1 over 9, or you can think 19 over 9. Therefore, my equation of curve is 3x minus 4, power 3 over 9, plus 19 over 9. Okay? Right. Now, sometimes they may give us the second order differentiation. Now, just recap, but in differentiation, we learned that if I differentiate my y, I'll get my dy dx. If I differentiate one more time, I'll get d square y dx square. Now, d square y dx square simply means the second order differentiation. Yeah. So if I want to find my equation of curve, I have to integrate twice. The first time I integrate, I'll get my dy dx. The second time I integrate, I'll get my y. So maybe I'll give you a class example. D square y dx square, let's say, equals to 6x minus 4. Okay. So you want to find dy dx. Okay, let's say they must give you enough information. They must say, okay, the curve passes through a point. Let's say the point is 1, 4. Yeah, and at this point, the gradient is now 2. Yeah, this information must be given. So when I integrate 6x minus 4 dx, I'll get 3x squared minus 4x plus c. Now you're going to have two different values of c. The first c is obtained when you integrate your second order, d squared by dx squared, right? I call it c1. At the point x equals 1, your gradient is 2. So I sub x with 2. My c1 should be 3. Then I rewrite this. Dy dx is now 3x squared minus 4x plus 3. And to find y, I have to integrate the second time. And this time when I integrate, this will be x power 3 divided 3. I'm going to write x cubed straight away. This will be 2x squared, because if you take x, you increase the power by 1, 2, divided by 2, 4 divided by 2 is 2. And then when you integrate 3, you get 3x plus the second c. I call it c2. And now we have to start in the coordinate 1, 4. When your y is 4, your x is 1, right? My c2 is still 2, is 2. Now, therefore, my equation of the curve is x cubed minus 2x squared plus 3x plus 2. Alright? So, that's all for the first part.